when an air is uplifted, it loses all its moisture, and when it gets denser, this dry air devoid of moisture falls back to the earth. And these two regions where the dry air falls back to the earth are called as subtropical highs. There are two subtropical highs, one is north and the other one is south. So the subtropical high pressure zone is formed due to subsidence of warm and dry air which is coming from equatorial low regions. So it occurs around 25 to 35 degrees north and south. And then high pressure is due to subsidence. So I've showed what is subsidence. Then high pressure is also due to the blocking effect of air because of the Coriolis force. So when studying about the subpolar low pressure belt, we'll see that just like in the equatorial low, there is upliftment, and this uplifted air, branch of uplifted air moves towards subtropical high pressure belt. Likewise, at the equator also, this is happening in the upper levels. The uplifted air moves towards subtropical high pressure belt, and this opposite movement creates a blocking effect. Usually the path is affected by Coriolis force, so it would look something like this. So this blocking effect gives rise to a high pressure belt where there is convergence in the upper layers and the air falls to the ground, and there is divergence at the lower layers. So the lower layers are associated with high pressure. So the high pressure system is due to blocking effect of winds which are moving in upper levels of atmosphere. So most of the deserts are present along this belt. This is the most important point. I'll explain this in the future slides. And these are also called as horse latitudes because high pressure belts, just like the low pressure belts, have a very calm movement of air because of subsidence. We have seen that subsidence doesn't create huge amount of high grade velocity winds at the surface. As a result, when ships used to travel between Atlantic or Pacific Oceans, and when they are traveling along this subtropical high pressure belts, they never had the help of winds in their movement. Hence, they had to use huge amount of manpower for driving their ships. But at a stage, they lost all their resources and they didn't have fodder to feed the horses which they were taking to trade or certain other purposes. So in such a case, they had no choice but to throw these horses into the sea, and hence these latitudes are called as horse latitudes. So this belt is frequently invaded by tropical and extratropical cyclones. So this is very important point, but we'll study about this in detail when studying about tropical and subtropical cyclones. So major hot deserts in northern hemisphere are located between 20 to 30 degree north and south and on the western sides of the continents. Why? This is the question asked in 2013 mains exam. So for this, the first important thing is the presence of subtropical high pressure belt. And again, the position of the subtropical high pressure belt is not fixed. It varies from season to season. For example, in summer, it moves northwards, and in winter, it moves southwards by a certain degree of 5 to 10 degrees. So this usually subtropical high pressure belt varies between 20 to 35 degrees north and south, and hence there is subsidence of air which is dry. Hence there are no rains in certain regions which lie under 20 degrees north and south, and hence few regions like Sahara, Kalahari, etc. are deserts because of the subsidence of dry air. And other than this, there are important factors like onshore winds and offshore winds, and also there is one more factor like cold currents which also influence the formation of deserts. So we'll complete this answer when studying about ocean currents. So we have seen what is upliftment, and then we have subsidence, and subsidence is the one that causes these deserts. Next, the winds that are blowing from high pressure belts are called certain winds which are blowing from high pressure belts are called as westerlies. We can see from high pressure belt we have wind movement towards subpolar low pressure belt, and this is in a direction which is from west to east, and they are called as westerlies. So these are the permanent winds. We have seen the first ones are trade winds or easterlies near the equator, and then the other ones are westerlies which occur around 35 to 60 degrees north and south latitudes. And one more important point here is the terms roaring 40s, furious 50s and striking 60s. And this phenomena occurs only in southern hemisphere, so these terms apply to only southern hemisphere. We know that southern hemisphere has little amount of land, and due to the presence of little amount of land, there is less friction offered to the winds that are blowing, and hence during 40 degrees north and around 60 degrees south, there are certain winds which blow at westerlies which blow at very great velocities. Hence they are called as roaring 40s, furious 50s and striking 60s. They are highly damaging for navigation, that is they create huge amount of trouble for ships. So these winds are important. Also they create a very very unstable environment, that is huge amount of cloud formation and rains. So this region is a very unstable region, that is between 40 degrees south and 60 degrees south, and this phenomena is not observed in north. This is very important point. So these terms apply to only westerlies which are happening between 40 degrees and 60 degrees in the southern hemispheres. And now let us see this map which explains the formation of deserts. If you look at this map, we have various deserts across the world. So we have deserts in Central Asia, and then we have deserts in the northern part of Africa, and then we have deserts, that is Saudi Arabia, Iranian desert, and then we have Great Sandy Desert of Australia and its small minor desert branches. And then we have Kalahari Desert, we have Patagonian Desert, which is a part of Argentina, and then we have something called as Atacama Desert, which is in Chile, and then we have Sonorian Desert, Mexican Desert, which is part of North America. So all these deserts have certain climatic features which are responsible for their formation. But if we consider deserts which are happening between 20 degrees north and 30 degrees north, as well as 20 degrees south and 30 degrees south, so these deserts which fall between these lines are the deserts which are greatly influenced by subtropical high pressure belts. So we have seen that at the equator there is upliftment, that is air is uplifted, and this uplifted air subsides near the subtropical high pressure regions, that is between 20 to 35 degrees north and south. So this upliftment subsidence is common in both the hemispheres, and this subsiding air being very dry doesn't bring rains to these regions. Hence there are a huge amount of desert formation in these regions. So if you see, Sahara is one such desert which is formed due to this kind of effect. And other than this, there is another important factors called as onshore winds and offshore winds. So before studying onshore winds and offshore winds, we need to know about intertropical convergence zone. Intertropical convergence zone is the zone where trade winds meet. We have seen that trade winds are the winds which meet near the equatorial lows. So when these trade winds shift their position depending on seasons, let us assume that it is summer, then the apparent path of the sun is along Tropic of Cancer. This is Tropic of Cancer. So in such a case, the equatorial low pressure belt is actually not at the equator, but it's to the north of equator. This is how it looks, usually traveling along Sahara, then Arabia and northern India, and this is how its path looks. When it comes to the ocean, it again approaches the equator. So this is the path of intertropical convergence zone during summer. So when equatorial low pressure belt has shifted in the form of intertropical convergence zone to this region, then the subtropical high pressure zone also shifts northwards by equal distance or somewhere closer to the same distance. And due to this shift in pressure belts, there is a wind system which is also shifting. For example, the winds that are traveling from southern hemisphere to northern hemisphere deflect due to Coriolis effect, and they move in this direction. And there are winds which are coming from the upper parts. So these winds touch here, so they both meet here. This is intertropical convergence zone. If you see, there are winds that are blowing in this direction, that is, they are easterlies, and there are winds which are coming from equator, they are westerlies. So if you see, they are merging at the intertropical convergence zone. So if you look at the zone of Sahara, so the winds that it is receiving are winds which are coming after following their paths through huge amount of continents. So if we see here, this wind which is flowing towards Sahara is traveling a very great distance. Hence all the moisture or cloud formation happens only at the coast. So there is huge amount of rain near the coast, but when it touches the intertropical convergence zone, all the moisture is lost due to continentality, that is very interior position of continents. And then the other path of air which is coming from the other regions, that is, you can say from subtropical high towards equator, even this air which is coming is passing through continents, hence it has no moisture in it. And this air which has no moisture simply has no rain bearing clouds, and hence there is no rain in certain regions like Sahara, Arabian desert, etc. So desert formation is mainly due to three reasons. One is due to presence of high pressure belts, and the other reason is due to offshore winds. So till now we have seen only about how convergence zone which is devoid of moisture bearing winds creates deserts, and now we'll see about how offshore winds also affect. Let us imagine that this is intertropical convergence zone. Somewhere around March or April, this will be the intertropical convergence zone. In such a case, there are winds that are blowing in this direction. So if you see, these are the winds which are blowing into the continents and they are leaving continents. So these winds are called as offshore winds, that is winds blowing from within the continents and they are leaving the continents into oceans. So winds that blow from continents to oceans are called as offshore winds. And if there are winds which are blowing from oceans towards continents, they are called as onshore winds. So if you see the position of Sahara and Arabian Desert, the winds they receive usually are onshore winds, that is winds that are coming from continents. So the winds that are coming from continents have no moisture and hence there is no rain bearing effect. Hence when there are no rains, there is no vegetation and the region will be a desert. So even offshore winds or offshore winds are the winds blowing from continent to continent also adversely affect the formation of vegetation, hence there is desert formation along this belt. And along with this there is something called as cold currents. So this is Canary's current, we'll study about this later. So the presence of currents also greatly influence desert formation. When there are cold currents, usually the temperature there is very cold, hence there is little evaporation. It creates a desiccating effect, that is in the atmosphere there is no moisture and hence there is no rain formation. So we'll see in detail about this when studying ocean currents. So remember two things. One is the desert formation is due to subtropical high pressure belts where wind subsides, which is dry, and the other one is due to offshore winds, that is wind flowing from continent to oceans. These winds are devoid of moisture and hence there are no rains along this region. But if you see the same region which is lying along the same belt, that is the India and some parts of Indochina, so these regions are not deserts because of presence of a phenomena called as monsoons. So monsoons are a different climatological phenomena which brings rains to these regions. So monsoons are the ones which are preventing the formation of deserts in this region compared to the desert formation in Sahara and surrounding regions. So consider the following statements. Either of the two belts over the oceans at about 30 to 35 degrees north and south latitudes is known as horse latitudes. So we have seen that subtropical high pressure belts are called as horse latitudes and they are present between 25 to 35 degrees north and south based on seasons. So this point is correct. Horse latitudes are low pressure belts. So horse latitudes are high pressure belts, they are not low pressure belts, hence this is wrong. Only one is correct. So let us move on to polar highs. So at poles the temperature is very low and hence there is increase in density of air in the upper levels of atmosphere. So if this is atmosphere, this is upper levels of troposphere, this is lower levels of troposphere. The wind or air in the upper levels is dense because of very low temperatures and this dense air falls to the ground, creating a low pressure at the upper levels and a high pressure at the bottom levels. So this bottom high pressure is called as polar high. So lowest temperatures along the poles creates this belt. So this is a thermal factors. We have seen that due to thermal factors there are two belts, one is equatorial low and polar highs. So these are formed due to differences very high and very low temperatures and causes subsidence of air and hence the polar ice. We have seen how there is subsidence at the poles because of greater temperature for lesser temperatures, and then they are very small in extent compared to other belts because of less land mass available. So depending on this subsidence we have two winds, one in southern and other one is northern hemispheres. They are called as polar easterlies. They blow from east to west and they are called as polar easterlies. So the winds that are blowing from polar high pressure zones move towards subpolar low pressure zones. Likewise, the winds blowing from subtropical high pressure zones, that is westerlies, also blow towards subpolar low pressure belt. So these winds are important in understanding formation of subpolar low pressure belt. So these winds are dry because they are subsiding winds and blow from high pressure area to the of the poles, that is we have seen they blow from high pressure area. So the direction is easterlies, and this is all discussed stuff. And the next important one is subpolar low pressure belt. This is very important, and this formation the formation of this belt is mainly depending on dynamic factors like Coriolis force and pressure differences. It doesn't depend on temperature. It occurs along 55 to 65 degrees north and south latitudes. Low pressure is due to ascent of air and convergence of westerlies and polar easterlies. So just like at the equatorial low pressure belt, there is upliftment or ascent of air. So there are two winds which are blowing towards subpolar low pressure belt. One is westerlies which are coming from subtropical high, and then there are easterlies which are coming from polar high. So these two winds converge at subpolar low and hence there is huge amount of pressure created at this region, and these winds, due to a blocking effect, are uplifted. So this upliftment creates a belt of low pressure between the uplifting air masses. So this belt is called as subpolar low pressure belt. A subpolar low pressure belt is formed not due to temperature effect, but due to dynamic factors like Coriolis force and pressure differences. So Coriolis force simply influences the path where they don't travel in straight line. They travel in curvy paths, and they move towards each other in opposite directions. Hence there is a blocking effect, and this blocking effect creates subpolar low pressure belt. So low pressure belt is due to ascent of air, that is upliftment of air, and in summer more developed and regular belts occur. So summer gives rise to more temperatures, and when there is more temperature, usually the upliftment is intense. Hence it gives rise to a continuous belt in summer, whereas in other seasons like winter, the belt is broken. And what we see here, the belts, they are continuous because we are considered the ideal cases. That is, we have assumed that the sun travels only at the equator, and then we have assumed that there is the same kind of landmass appearing in both north and south. But in real situations, the pressure system doesn't appear like continuous as we see in this figure. They are broken. We'll see later in later figures. So there are two distinct lows, one at Aleutian Islands, other one is at Greenland. We'll see that in a figure later. So cyclonic storms or lows are produced in the region. Mainly frontal cyclones occur in this region. They are not tropical or subtropical cyclones. They are called as temperate cyclones, which are also called as frontal cyclones. They are formed mainly due to various phenomena like air masses and jet streams, about which we'll study later. And then consider the following statements about roaring 40s. So previously we have talked about roaring 40s, furious 50s, and shaking 60s. They are a phenomena which are unique in southern hemisphere. That is, they are absent in northern hemisphere. So they blow uninterrupted in the southern hemisphere. This point is wrong because they blow only in southern hemisphere and not in northern hemisphere. And then they blow with great strength and constancy. We have seen that due to absence of land, huge amount of land, there is less amount of friction offered, and hence they are at great speeds. Hence the point is correct. Their direction is generally from northwest to east in the southern hemisphere. So if you just look at their direction, they blow from northwest to southeast. Hence this point is also correct. Overcast skies, rain, and raw weather are generally associated with them. So horizontal movement of air along the oceans carries huge amount of moisture with them. Hence there is cloud formation and also rains. So this point is also correct. The answer except one. So this one is the answer. Westerlies in southern hemispheres are stronger and persistent than in northern hemisphere. Why? So we have seen that in southern hemisphere, westerlies are stronger because of absence of land mass. So there is less land mass as compared to northern hemisphere. So the point one is correct. The Coriolis force is higher in southern hemisphere and as compared to northern hemisphere. We have seen that Coriolis force is an apparent force which is independent of region. It only depends on rotational effect. So rotation in both southern hemisphere and northern hemisphere is same. Hence the Coriolis force will be same. So this point is wrong. So the answer is only 1. So initially when we started this video, we have talked about factors controlling pressure systems. Two factors, thermal and dynamic factors. We have seen how thermal factors produce equatorial low and polar rise. So with this we'll have a complete understanding of thermal factors. We have seen how these belts, that is equatorial low and subpolar low, are formed due to thermal factors. Sorry, equatorial and polar high are formed due to thermal factors. And then we have seen that is due to dynamic factors like blocking effect and Coriolis force, how other belts are formed, that is subtropical high and subpolar low. So this is how pressure systems look in actual terms, not in ideal cases. We have seen that the northern hemisphere has great amount of land mass, hence the amount of heat received by northern hemisphere is greater, as well as in winters the coldness here will be much greater, whereas in southern hemisphere there is ocean which is dominating. So oceans have a different kind of properties, and their influence on temperature is totally different because the changes in temperature occur very slowly because of huge amount of water. So the presence of intertropical convergence zone also varies from season to season. We can see this is somewhere around is the equator, somewhere little to the north. So if you see intertropical convergence zone, it fluctuates, but most of it lies in the southern hemisphere. This is because of the apparent movement of the sun towards southern hemisphere in winter, that is when it's winter in northern hemisphere. Let us see about another one, that is in July. If you see in July, the intertropical convergence zone migrates to the north. So it travels somewhere along the line of Tibetan Plateau and then along the Saharan belt. So we have seen how the winds that are blowing deep into the interiors have no moisture, and hence there is no rains in Sahara when the intertropical convergence zone is along Sahara. So when the intertropical convergence zone comes southwards, if you see this is coming southwards because of in winter season. So here the winds are affected mainly by the region is affected by offshore winds. So offshore winds are the ones which are flowing from continent oceans. So these winds are lack moisture and hence there is no rains. So this is one more example for desert formation. And we can see that the high pressure and low pressure centers are not continuous, they are broken. So high pressure and low pressure centers are never continuous, they're always broken because of differences in temperature between land and water. And we can see in January there are two lows, one at Aleutian Island, Greenland, other one is at Aleutian Islands. So this is low at Aleutian Islands. So this is about pressure systems. Let us take a look at question. Assertion: 60 degrees 65 degrees latitudes in both the hemispheres have a low pressure belt instead of high pressure belt. So we have seen that there is subpolar low pressure belt in this region. So the assertion is correct. The low pressure areas are permanent over oceans rather than on land. So if we look at the figure, previous figure, we can see that the high pressure and low pressure systems are continuously broken, so they don't depend on whether it's ocean or continents. So their presence depends mainly on various other climatic features like the amount of land and oceans. So they are not continuous, they are always broken. So the option 2 is wrong, because the low pressure areas are permanent over oceans is wrong, because they are not permanent both on oceans as well as land. So answer is only A is true but R is false. And again, another important point is, usually if you see this is summer in northern hemisphere, and we see that two lows, the low at Greenland, and then we have a low at Tibetan Plateau, and we have a low at Rockies. So these are land masses which have a great amount of mountainic land mass, and these lows are formed due to intense heating. So intense heating creates these land masses. So usually continents are associated with lows in summer, whereas oceans are associated with highs. So the exact opposite happens in other season. So this is all about pressure systems. And then we have different kind of cells called as atmospheric cells, which are called as Walker cell, which we will study about while studying El Nino. And then we have Adley cell, Ferrel cell, and Polar cell. So these cells are formed due to continuous circulation of air. We have seen that there is upliftment at the equator, and this air moves and subsides at the high pressure region. So this is a continuous cell, so which creates Adley cell. And similarly we have Ferrel cell and Polar cell. So if you see the path, they are not straight lines, they are curvy paths because of Coriolis force. Apply Coriolis force to these paths, you'll understand how the deflections are happening.